Hey guys, I'm MikroTik Marc with Admiral Centralized MikroTik Management, and recently we had a support question related to asking about FCS errors. In a MikroTik, each interface tracks errors, and the Admiral dashboard provides alerts on FCS errors, so one of our users wanted to know, what is an FCS error, and what should you do about it? FCS stands for Frame Check Sequence, and CRC stands for Cyclic Redundancy Check. And both are a mechanism for ensuring that what a sender sends is the same message as what a receiver receives. So let's break that down a little bit. Remember that childhood game where you sit in a circle and whisper something to your neighbor, and then it goes all around the circle, whispering neighbor to neighbor until it gets back to you? If the message you whispered to start things off isn't the same as the message whispered back to you at the end of going around the circle, then you know the message was corrupted. It changed during the sending and receiving process. As kids, it felt like it was impossible to get the same message at the end as the one that you started with. Fortunately, with computers, the message is digital instead of analog. It's all ones and zeros instead of whispers, and it's incredibly easy for any computer to mathematically identify if any corruption has occurred on the message. Computers are insanely good at exact copies of messages. So what happens is that when creating the strings of ones and zeros to transmit the data, the sender runs a predetermined algorithm against the block of data and comes up with a mathematical answer called a checksum. So the sender says, here's a frame worth of data, and then at the end of it, here's my math answer to running this frame's worth of data through an FCS algorithm. It's like taking a test question, writing down the answer after it. Then the receiver takes that stream of data that includes the frame of ones and zeros and the checksum at the end, and he runs the exact same FCS math algorithm against that frame's ones and zeros. And if no corruption has occurred, he'll get the exact same answer. FCS is there to verify that what you sent and your answer to the test question is the same as what I received and my answer to that same test question. 99% of the time, the FCS of the sender and receiver matches. And that means that the ones and zeros that were sent were exactly the same as the ones and zeros that were received. So what happens if the FCS doesn't match up? Well, in that case, we drop that frame and throw it away. It's a dropped packet at the interface that has received it because, guess what? It's bogus data. Somewhere along the way, one or more ones and zeros got all screwed up, and now we can't trust that data anymore, so might as well throw it away. But wait, now you're asking, won't throwing away frames and packets be bad for the network? Wouldn't a user notice that happening? Well, the answer to that question is, it depends. If we throw away one frame out of every 1,000, or maybe one frame every couple of days, things won't be very bad. Almost all applications use TCP, or Transmission Control Protocol. And that's a stateful and reliable protocol, and that's a topic of another conversation, but rest assured that 99% of the time, losing one packet here or there will not be perceptible to a user. Even if that traffic is UDP or otherwise unreliable, most applications are okay with a tiny amount of data loss. But what if we increase FCS errors every hour, every minute? What about every second? The more frames that our switches and routers discard, the worse the user experience is going to be. If we get up to a 1% packet loss, meaning we throw away more than 1 out of every 100 frames, it is guaranteed that a user will notice that the network is incredibly slow, as applications keep asking for retransmission of lost packets, and real-time applications like voice or video, they will get choppy, tiling, artifacting, and even those robot voices you may have sometimes heard. So now what? On the plus side, FCS errors are almost always an indicator of a physical layer problem, and they're always a problem that you need to take some action on if your counters are incrementing. So here's what you can do. First, and most likely, maybe you just have a bad cable. Replace that cable or the connector, and it doesn't matter whether it's copper, fiber, or even a wireless link. If you made the cable yourself, you could try re-terminating the connector because it could just be the connector itself that is bad and the cable is still good. If it's a fiber optic cable, a heavy bend or sag at the end of the cable when cable management isn't at its best can be the cause of FCS errors, and just adding a little tension loop or relaxing the bend at the end of the cable with some additional support can prevent FCS loss. Up next, maybe you have a bad port. You can change your configuration and move your traffic from, for example, let's say Ether 2 to Ether 3. Here's a tip. If you move your traffic and that move of traffic fixes your FCS problem, please make sure to mark that old port as bad and disable it so that you don't plug something else into it and start this rabbit hunt all over again. I speak from experience. Update your firmware. Your device could just have a bug in the interface processing software driver, so make sure your firmware is up to date. Next up, it could be a speed duplex mismatch. You could try forcing the speed and duplex to match at both ends of the connection as appropriate to your link. Use care here because if you pick a speed and duplex that the devices don't actually support, you could lock yourself out until you have local physical access to the UI while directly attached to the device. Also, it could be a faulty entire MikroTik, motherboard, or switch, so if you get this far, you could try replacing the entire MikroTik itself, or the device at the other end connected to the MikroTik at the other end of the cable. One thing to note, in case you haven't noticed, FCS errors will not tell you exactly where a problem is. Whether the sender is sending you garbage, or whether a receiver is making garbage out of a perfectly good message, or whether somewhere along the transmission path, like that fiber optic or copper cable, or even wireless between the network devices, something is totally messing with our stream of ones and zeros on the way between the sender and the receiver. And it could even be the sender or receiver itself that is corrupting that message. Okay, finally, it could be something completely external to networking that's interfering with the transmission. For example, if it's a copper cable like a Cat7 patch cord, and it's run next to a strong power source in the same conduit, for example. Maybe you've got some bright lights or an appliance like a microwave or whatnot. RF interference can be introduced from the power lines into the data lines. Coincidentally, this is the reason that inside the sleeve of your Cat7 cable, there are 8 wires that are tightly wound. The induction of the signal along the intertwined wire, called twisted pair, helps to prevent RF interference and crosstalk. So cool. Well guys, hopefully this video has helped you understand what FCS errors are, how they happen, and what you can do about them. If you learned something and enjoyed this video, be sure to like and subscribe to our channel for more content. And if you operate a MikroTik network, you should check out AdmiralPlatform.com, where we help centralize visibility, control, and automation for MikroTik networks of any size and scale. See you next time, and keep routing the world.